we're going to start doing some work here. In physics, work is when you take a force vector and you dot product with the distance vector. So that means if you're applying some sort of force on an object and the object moves a certain distance, you can figure out what that work is, and work is useful when you're doing some applications. So for example, I'm going to draw a box diagram here, and so we're going to say that someone is applying a vector force, and that force is 10, -3. So the force is going 10 over, but it's also being pushed down -3. Now the distance vector, we're going to say the box after that force was applied, the distance moved was 5, 0. So this is F, this is D. To figure out the amount of work actually done on the object, we dot product those. So work would be 10, -3, that's our force, dotted with the distance it actually moves. Oops, I was thinking distance, which is 5, 0. When I dot product this, 10 times 5 is 50, -3 times 0 is 0. So we would just say that the work done is 50. And in this case, I guess, you would use something like Newton meters. But we're not going to worry too much about the units, just know that 50 is the work here. So it's easy when both of those things are two vectors. Another example, work gets a little more complicated when, for example, we have a wagon here, and if we're pulling the wagon along, the vector is going to be leaning like this. Now, one way to write this is that we are exerting 20 pounds of force. That's our magnitude of that vector. And the angle that we're applying it is 60 degrees. Now we also know that it moves 100 feet forward. Okay, so for the distance vector, I can do that really quick. 100 forward is just a positive 100 in the x, and it's not going to go up and down at all, so that's 0. For the force applied, though, we don't have an x and a y here. We have a magnitude and an angle. But if you remember from back to our trick, you can do r times the cosine of theta for x, and r times the sine of theta to get your y. That's just a quick trick. So I'm going to do 20 times the cosine of 60 to get my x. Then I do 20 times the sine of 60 to get my y. So really, when I crunch this out, I have to use a calculator here. 20 times the cosine of 60, that would be 10. If I do the same thing with sine, that's going to be 17.32. Now the idea is that if I do distance dot product with my force, that is the work done. And now that I have xy and xy, I can dot product them. So 100 times 10 is 1,000, plus 0 times that is just 0. Turns out the work here is 1,000. The units for this would actually be foot-pounds. I think that means the amount of pounds per foot, kind of. But that, again, is not important. Just make sure that you can get these numbers here. So remember, if you have one that is not written as an xy vector, you have to change it using the magnitude and the angle.